Hello, this is Dr. Hanaa Assil, and this is paper 2CR of June 2022. So the first question here was the diagram shows the subatomic particles in an atom of an element. Give the name of each of the subatomic particles labeled P, Q, and R. What is P? Can you see P? P is something that doesn't have a charge and it's inside the central part of the atom, so P must be neutron. Now, Q is the positively charged particle in the center of the nucleus. Which particle in the atom is positive? You should realize that is the proton. Then what is R? Can you see where R is? R is the negatively charged particle that rotates around that central part. So which part of the atom is negatively charged? You should realize that it is the electron. Then the question says, give the name of the part of the atom labeled S. So that central part in the atom is called what? It's called nucleus. Now, give the name of this element. How do I know the name of this element? Remember that in order to identify this element, I count the number of protons. How many protons does it have? It has a total of 5 protons. Remember, proton number or atomic number is the one that identifies an element. So this element has 5 protons. I go to the periodic table and I look for what? I look for the element that has the small number 5 or the atomic number 5. So you find that you know that the elements in the periodic table have 2 numbers. The bigger number is the mass number. The smaller number is the atomic number or the number of protons. So the one that has atomic number 5 is boron. Then we say a potassium permanganate crystal is placed in a beaker of water. After several days, a colored solution forms. Now, you probably know that potassium permanganate crystals are purple in color. So what happens if I put a purple crystal of potassium permanganate in a beaker of water? Now, the first thing that would happen is dissolving. He says, give the names of the 2 processes. So the first process is the crystal will start to dissolve, and then we have what we call diffusion. So the purple color or the purple crystals will start to move randomly, spread randomly through the water from area of high concentration to area of low concentration. So that is called diffusion. The formula of potassium permanganate is KMnO4. How many different types of atoms are there in KMnO4? Remember that sometimes he asks how many different types of atom and sometimes he asks how many atoms. Here he's saying how many different types. Well, let's take a look. I have K. If you look at the periodic table, or you probably know, K is potassium, Mn is manganese, and O is oxygen. So how many different types of atoms? I have 3 different types. But if he were asking how many atoms, then I would say I have 1 potassium, 1 manganese, plus 4 oxygens. That means I have 6 total number of atoms. But the types of atoms, I have only 3. Calculate the relative formula mass of KMnO4. How do we calculate the MR of something? We look at the periodic table, and now we're looking at what? We're looking at the mass number of each one. That means I'm looking at the big number of each one. So potassium has a mass of 39. Manganese has a mass of 55. Oxygen has a mass of 16. So I add all of these up. I have only 1 potassium, 1 manganese, but I have 4 oxygens. Remember that 4 applies to the oxygen. So I have 16 times 4. You add them all up, it comes to 158. Potassium permanganate can be used as an oxidizing agent. State what is meant by the term oxidizing agent. You have to remember when we were talking about oxidation, reduction, and oxidizing agent and reducing agent, the oxidizing agent is the substance that gives oxygen or loses oxygen. So when it gives the oxygen to something else, it makes that other substance oxidized. So actually, the oxidizing agent is the substance that is reduced. When it gives up oxygen, it becomes reduced, but it oxidizes the other substance. Okay? This question is about alkanes. Do you remember what we know about alkanes? He's asking which of these is the molecular formula of an alkane. Okay, let's remember, what did we say about alkanes? We said alkanes are a group of or a homologous series of organic compounds. They all have the general formula CnH2n plus 2. That means in order to be an alkane, the number of hydrogen is twice the number of carbons and add 2. So we have CH4, C2, H6, C3, H8, and so on. The number of hydrogen is twice the number of carbons plus 2. And if you remember, the functional group of alkanes was the fact that they have single bonds between all the carbons. So let us look at which of these is an alkane. C2H5 does not obey the rule of CnH2n plus 2. It should be, if I have 2 carbons, I should have 2 times 2 is 4. Plus 2, it should be C2H6. So A is wrong. What about C4H10? Well, C4H10, if I have C4, that means I have hydrogen. 2 times 4 is 8, plus 2, 10. So this is actually my answer. What about C? C does not follow the general formula. If I have 2 carbons and 4 hydrogens, this is actually an alkene, not an alkane. What about D? D does follow the rule of CnH2n plus 2. I have 3 carbons, 2 times 3 is 6, plus 2, 8. This is correct, but this is not my answer. Do you realize why this is not my answer? Because he's asking for molecular formula. Molecular formula means the total number of carbons. You add up all the carbons and you add up all the hydrogens together. So the molecular formula is C3H8, not what you have in D. So it is not the answer. Okay? Which of these has the same empirical formula and molecular formula? So, do you remember what is meant by empirical formula and molecular formula? We said before that empirical formula is the formula showing the simplest ratio between the elements. So the ratio between the elements should be the simplest ratio possible. You cannot simplify it further, then that is called empirical formula. What about molecular formula? Molecular formula is the formula showing the actual ratios between the elements. So which of these can be both? Well, let's take a look. What is CH2? CH2 cannot be a molecular formula. It can be an empirical. You can have simplest ratio 1 to 2. So this can be empirical, but it cannot be molecular. Molecular formula means it should follow the general formula of CnH2n plus 2 or CnH2n and things like that. So this is not the answer. What about C2H6? Well, C2H6 can be a molecular formula, but it is not empirical. Do you understand why it's not empirical? Because you can simplify the 2 and the 6. So actually C2H6, its empirical formula would be CH3, because you can still simplify the 2 to 6. What about C3H8? Well, C3H8 can be the molecular formula of an alkane. Remember we said CnH2n plus 2. So 2 times 3 is 6 plus 2, 8. So this can be a molecular formula. And it is also the empirical form because you cannot simplify it further. So if you have B, you can simplify it to CH3. But C3H8, you cannot simplify it further, so this is also an empirical formula. C4H10, of course, does not apply because you can simplify it, so its empirical formula will be C2H5, so my answer is C. In the presence of ultraviolet radiation, methane reacts with bromine to form bromomethane and hydrogen bromide. Do you remember the reaction of alkanes with halogens? You should remember that alkanes with halogen was a free radical substitution reaction. So the name of this type of reaction is substitution. Okay, give a chemical equation for this reaction. He's saying what? Methane, what is methane? Methane is CH4 plus bromine. Again, I'm reminding you that bromine is diatomic, so you have to write it Br2. And what we do in alkanes plus halogen is we remove one of the hydrogens and put one bromine instead of it. So my product is CH3Br. And the H that I removed plus the other Br from the Br2, that is my other product HBr. So remember that this is the reaction for alkanes with halogens. Then here he says 1 mole of an alkane burns completely in oxygen. The equation represents the reaction. The numbers X, Y, and Z are used to balance the equation. So the problem here is I have an alkane, but I don't know what is its molecular form. So I don't know what is X and what is Y and what is Z. And he did an experiment. He said the complete combustion of 1 mole, again, combustion means burning in oxygen. The combustion of alkanes give carbon dioxide and water. So he says it produced 220 grams of carbon dioxide, 108 grams of water, and he wants me to find out what is Y and what is Z. Okay. Of course, if he gives me the mass of each of these, the first thing I should do is get the number of moles. Remember that Y and Z are actually the ratio of moles of each of these. So what is the number of moles? How do we get it? Mass over molecular mass. I have mass, so 220 over the molecular mass of carbon dioxide, and he actually gives it to me. This means I have 5 moles of CO2. Then we need to get the number of moles of water. Again, how do we get number of moles of water? It's mass over molecular mass, and this gives me 6 moles of water. And that means that the ratio in that equation, I end up with 5 moles of CO2 and 6 moles of water. So that means that Y is 5 and Z is 6. Then he says determine the molecular formula of the alkane. Let's continue in that equation. How do we get what is the molecular formula of the alkane? Well, we try to balance this equation. We started with 1 mole of the alkane, so I cannot put any numbers in front of it, but I need to get what is Y and what is Z. So if after the arrow I have 5 carbons, that means before the arrow I also have 5 carbons. Now, after the arrow, I have how many hydrogens? I have 12 hydrogens, and that means that Z is 12. Now, we balance it to get what is X. So if you balance it, how many oxygens after the arrow? I have 2 times 5 is 10, plus 6 oxygens, so that is 16. So before the arrow, I need 2 times 8. And that means the molecular formula is C5H12, and X, which is the coefficient of oxygen, is 8. When an alkane burns in a limited supply of air, incomplete combustion occurs. Explain why incomplete combustion of an alkane could be harmful to humans. Remember, we said if we have complete, that is a lot of oxygen, then it gave carbon dioxide plus water. But if I have a limited supply of oxygen, then it does incomplete. What does it form? It forms carbon monoxide plus oxygen. What is the problem with carbon monoxide? Carbon monoxide is toxic. Now, why is it toxic? Remember, he says explain why it's harmful. It is toxic because it reduces the capacity of blood to carry oxygen. Remember, we said that carbon dioxide will bind to the hemoglobin in the red blood cells. So the red blood cells, instead of carrying oxygen, will be carrying carbon monoxide. So less oxygen is going to the cells. Okay, the next question says the diagram represents the structure of copper metal. You know that when we draw metals, metals are layers of positive ions surrounded by a sea of delocalized electrons. And he's saying explain 3 properties of the metal that makes it a suitable metal to use in electrical wiring. So which properties can we talk about with respect to electrical wiring? Why is copper a suitable metal for electric wires? Well, we can talk about the fact that they conduct electricity. So why does copper conduct electricity? He says explain. Please do not forget the word explain. Don't just say it conducts electricity. Well, why does it conduct electricity? Because it has free moving delocalized electrons. It has free moving electrons. Remember, metals conduct electricity because they have free moving delocalized electrons. These electrons, they are the electrons in the outer shell of each atom, and the atom doesn't want 1 or 2 or 3 electrons in the outer shell, so they're just floating around, so that allows it to conduct electricity. Then, what other properties can we talk about? Well, obviously, you should realize that metals are malleable and ductile. Why are they malleable and ductile? Because what does malleable and ductile mean? We said malleable means it can be spread out into sheets, like aluminum foil, for example. And ductile means it can be pulled into wires. So we say that copper is a suitable metal for making wires because it is ductile. Now, why is it ductile? Because layers of positive ions can slide over each other. So remember that any metal, when heated or hammered, the layers of positive ions can slide over each other, so you can reshape the metal. Okay, we need a third property. He says explain 3 properties. What is the third property? The fact that metals like copper have high melting point. Now, why does it have high melting point? Remember that this is due to the strong attraction forces between the positive ions and the delocalized electrons. We know that positive ions and negative electrons will have strong what we call electrostatic attraction forces between them, and this needs a lot of energy to be broken, so it will have high melting point. Okay, the next question, or the next part of the question, says the diagram shows electrolysis of copper to sulfate using graphite electrodes. Copper forms at the negative and the oxygen forms at the positive. Give the formula of the copper ion and the formula of the sulfate ion. So first of all, what is the formula? Please remember formula, not name. Formula of copper ions, you should realize that copper ions are copper 2 plus, that is 2 plus. You know that copper has a valency of 2. It's a metal that loses electrons, so it's copper 2 plus. How do we write sulfate? Sulfate is SO4, 2 minus or minus 2. Remember, we can say 2 minus or minus 2. So these are the formulas of the ion. So he's doing electrolysis, and he says, state what would be seen at the positive electrode. Remember, he mentioned what is formed, but let us go over how do I know what is formed at each electrode. We have copper 2 sulfate, and that means the first thing I ask myself is, what type of ions do we have? If I'm copper sulfate, that means we have copper 2 plus and sulfate 2 minus. But this is also a solution, and remember that water will ionize to form H plus and OH minus. Now, the next question would be which ones will go to the positive and which ones will go to the negative. Remember that the negative ions go to the positive. The positive ions go to the negative. Then we have a choice of which one will react. So if we say that sulfate and hydroxide go to the positive, which one will react? Well, you should realize if we have a choice between sulfate and hydroxide, it is the hydroxide that will react. If we have a choice between copper 2 plus and H plus, it is the copper 2 plus that will react. And that means if the hydroxide reacts, it gives oxygen. And if the copper 2 ions react, that will give me copper. So he's saying, state what would be seen at the positive if something gives out oxygen. What would you see? Oxygen is a gas. Your observation is bubbles of gas or fizzing or effervescence. Remember, don't say the observation is or what would be seen. You just say oxygen gas. That's not what I see. What I see is bubbles of colorless gas. Then he says, give a test for oxygen. What is the test for oxygen? Remember, we said for oxygen, we use a glowing splint. So we say the glowing splint relights, or insert a glowing splint, it relights. This is the test for oxygen. Give an ionic half equation for the formation of oxygen at the positive electrode. Remember we said the hydroxide ions are the ones that will react at the positive. Now when the hydroxide ions, remember that the negative goes to the positive to lose electrons. Now when the hydroxide ions lose electrons, we said they will form oxygen plus water, and you need to balance. So this would be the balancing of the equation, and this is what we call ionic half equation. Suggest why the copper sulfate solution contains some hydroxide ions. We said, where did the hydroxide ions come from? They came from the ionization of the water molecules. This is a solution. If it were molten, when we do electrolysis of something that is molten, there is no water, so there is no hydroxide. But if we're doing electrolysis of a solution, then the water molecules in the solution ionize to form H plus and OH minus. This question is about alcohols, carboxylic acids, and esters. Ethanol can be manufactured by the fermentation of a solution of glucose. Do you remember the meaning of fermentation? Fermentation is when the glucose is changed to ethanol plus carbon dioxide. So we put glucose solution and this changes to ethanol and carbon dioxide. Now, he wants word. Please remember, if he asks for word, you need to give him word equation. Then he says, state the substance that needs to be added for the reaction to occur. What do we add to glucose in order to do fermentation? Remember that we add yeast. So the yeast will break down the glucose to form ethanol, and carbon dioxide gas comes out. You know that the test for carbon dioxide gas is that if I pass it through lime water, the lime water becomes milky. So that's the reaction. Then he's saying state two conditions needed for this reaction. Now, if I want to do fermentation, we said we add yeast to the glucose. What are the other two conditions? Remember, what temperature do we do this? This is something that involves enzymes, because if you put yeast, this involves the zymase enzyme. So you need to do it at a relatively low temperature. You don't do it at 70 or 80 or the enzyme will be denatured. So fermentation is usually done at 30. You can say 35 also. And this is what we call anaerobic respiration. Anaerobic respiration means I need to do it in the absence of oxygen. I do not allow oxygen to go into the reaction. If I allow oxygen to go into the reaction, then I don't get ethanol, I get ethanoic acid. Okay, in the presence of an acid catalyst, ethanoic acid is heated with butanol to form an ester. Do you remember how to draw an ester? An ester is made from acid and alcohol. And we said when we draw it, the first part is the acid. So this is from ethanoic acid. So I have two carbons with double bond O. This is the part from the ethanoic acid. Now, it is using which alcohol? We're using butanol. So that second part of the molecule is a butyl part. So it is something that has four carbons. So of course, if we were to name this ester, it would be called butyl ethanoate. But he's asking for the formula of the ester. So you need something that has two carbons, two oxygens, and then four carbons. So that is the second one. The others are wrong. They do not give the correct formula for the ester that is formed. State how you would know that an ester has formed. When we do this kind of reaction, acid plus alcohol to give ester, do you know how do we know that an ester has been formed? An ester has a characteristic fruity smell. So this is used as a test to identify the presence of esters if the reaction gives a fruity smell. Give one use of an ester. If it's something that has fruity smell, we said, what do we use esters for? We can use them to make perfumes or to make food flavorings for to give the food characteristic smells. Aspirin is a compound used to reduce pain. Aspirin contains a carboxylic acid functional group and an ester functional group, and he's saying state what is meant by the term functional group. What do we mean by functional group? Remember we said we have alkanes, alkenes, alcohols, acid. How do I know if a compound belongs to a specific homologous series? If I see something specific that identifies it. So you should realize that the functional group is the part of the molecule that determines which homologous series it belongs to. So for example, the question on alkane, we said I know it's an alkane if it has single bonds between the carbons. So the single bonds between the carbon is the functional group. Or you probably remember that if I want to know if something is an alcohol, then it should have an OH and so on. So that is called the functional group. So this is the part of the molecule that determines which homologous series it belongs to, whether it's an alkane or alkene or alcohol or acid, or it is the part of the molecule that determines its chemical properties. Of course, if I decide that it's an alcohol, then it will do specific reactions. If it's an alkane, then it does specific reactions and so on. This is the structural formula of aspirin. Draw a circle around the carboxylic acid functional group. Now, we're saying that this compound has an acid group. Where is the acid group? You should know that any organic acid should have this group, C double bond OOH. So this is the functional group of carboxylic acid. Aspirin has this percentage composition by mass. Show by calculation that the empirical formula of aspirin is this. How do we calculate empirical formula from percentages of the elements? Remember, we write the percentages. Carbon is 60, hydrogen 4.44, oxygen 35.56. And then we go through two main steps. What's the first step? Divide by the mass number. So carbon has a mass number of 12 from the periodic table. It is the big number from the periodic table. So you divide the 60 by 12, the hydrogen by 1, the oxygen by 16, and you get certain numbers. Now, what's the next step? These are ratios. I need to simplify them. In order to simplify them, I divide through by the smallest. So which of these is the smallest? 2.22. I divide all of them with 2.22. So I get these numbers. Now, if one of them comes out 2.25, do not round it up to 2. If it is 2.0 something, then you write it 2. But if it is 2.25, then you need to find the number that you can multiply all of these so that it becomes a whole number. I want it to be a whole number. So if I multiply by 4, then all of these would be whole numbers. 2.25 by 4 is 9. So I multiply all the ratios by 4. And that means my empirical formula is the correct one that he mentioned up there. Okay, so divide by the mass number, which is the big number from the periodic table, and then divide by the smallest and look at the ratios if you need to multiply through by something so that it's a whole number, and that will give you the empirical form. Okay, question 6 says a student uses this method to do titration. You remember what is titration? He used a measuring cylinder to obtain 25 centimeter cubed of sodium hydroxide solution, transfer the solution to a conical flask, add a few drops of universal indicator to the flask, fill a burette with dilute sulfuric acid, record the initial burette reading, add the acid to the flask, swirling the flask continuously, add the acid slowly near the end point, record the final burette reading at the end point. So this is how someone does a titration. We said we use a burette to add the acid, and we have a base in the flask and indicator in the flask. So he says the student repeats the titration until at least 2 concordant results are obtained. You remember what we mean by concordant results? We said we repeat the titration until my results are within 0.2 centimeter cubed of each other. So they shouldn't be far apart. They should be, the difference between the results should be 0.2 or less. If it is too off or too far away from each other, then these are not suitable, and I need to repeat the experiment until we have results that are within 0.2 centimeter cubed of each other. So we call that concordant results. Then he says, explain 2 improvements to the student method so that more accurate results are obtained. Let's look at the student method. What is wrong with the student's method that we should improve? Well, let's see. The first thing is he used a measuring cylinder to obtain 25 centimeter cubed of sodium hydroxide. Remember, when we do titration, we put 25 centimeter cubed of sodium hydroxide into the flask using what? We don't use a measuring cylinder, we use a pipette. So he should use a pipette, and he says explain. He should use a pipette instead of measuring cylinder because this will give a more accurate volume of sodium hydroxide. Please do not forget explain. So don't just say use pipette. Why are you using pipette instead of measuring cylinder? Because the pipette is more accurate, or it will give you a more accurate volume. Okay, let's take a look at the procedure again and see what can we improve. Well, what did he do? He added a few drops of what? Which indicator is he using? He's using universal indicator. You have to remember, we never use universal indicator in titration. Remember, universal indicator is something that changes color at each pH. So I cannot use universal indicator. I need to use something like methyl orange or phenolphthalein or thymolphthalein, for example, okay? We need to use an indicator that has a sharp color change. So methyl orange, for example, would change directly from yellow in a base to orange when it is neutral. But if we were using universal indicator, the universal indicator changes color at each pH. So no sharp color change at the endpoint. So that is not suitable for titration. He says the student makes the improvements, repeats the titration. Sulfuric acid has this concentration. Sodium hydroxide has this concentration, and this is the equation. Then he says calculate the volume of sulfuric acid that the student needs to completely react with 25 centimeter cubed of sodium hydroxide solution. Okay, what do we do? He's giving me information about what? He's saying I have sodium hydroxide, concentration 1.5, volume 25. I can use that to get the number of moles of sodium hydroxide. So the number of moles of sodium hydroxide is concentration times volume. I'm reminding you the volume is in centimeter cubed. In order to put it into the equation, we have to divide by 1,000. This gives me number of moles of sodium hydroxide. Then we look at the equation. Where is the equation? The equation says 2 moles of sodium hydroxide react with 1 mole of sulfuric acid. Remember, if there is no number, it's 1. So it is a ratio of 2 to 1. So if the sodium hydroxide is this number, then what would be the number of moles of sulfuric acid? It's half of it. So that is how we get number of moles of sulfuric acid. Then what is he asking about? He's asking about the volume of sulfuric acid. How do we get volume of sulfuric acid? It's number of moles over concentration. He gives me the concentration of the acid up there, so I get the volume. Remember, the volume that comes out is in decimeter cubed. He doesn't want it in decimeter cubed. He wants it in centimeter cubed, so I have to multiply by 1,000, so my answer is 31.25 centimeter cubed. The student plans to obtain pure dry crystals of hydrated sodium sulfate. They add the calculated volume of sulfuric acid to 25 centimeter cubed of the sodium hydroxide to form sodium sulfate solution. So now he has sodium sulfate solution, and he's saying describe what the student should do to obtain pure dry crystals of hydrated sodium sulfate from the solution. So basically he wants you to explain what? Crystallization. Remember, I have a solution and I want crystals. How do we do crystallization? You should remember that first I have to heat the solution to point of crystallization. Then I need to leave it to cool. So when it cools, it will form crystals. And then I need to filter the crystals to get it in the filter paper and funnel. This is how you do the crystallization. He wants to obtain pure dry crystals. Again, the first thing you do, heat the solution to point of crystallization or to evaporate most of the water. Cool to form crystals. Remember, after we heat, we need to cool, then it will form crystals. Then we filter the crystals through filter paper and funnel, so we get the crystals as residue in the funnel. Wash with a few drops of distilled water, and we need it dry. Remember, these are hydrated crystals. I should dry between filter papers, not in an oven, so that we don't lose the water of crystallization. In presence of an ion catalyst, nitrogen reacts with hydrogen to form ammonia. The reaction conditions used are temperature 450 degrees Celsius and pressure 200 atmospheres. And this is the equation for the reaction. First, he says, state what this symbol represents. Of course, you remember that this symbol represents that the reaction is reversible. Remember, when a reaction is reversible, this is the kind of arrow that you put. And then he's saying up there that we use the ion catalyst. So give the reason for using a catalyst. Do you remember what's a catalyst? A catalyst is something that speeds up the reaction. So when you put a catalyst on a reaction, this is just to speed up the reaction or to make it fast. The reaction mixture is kept at a pressure of 200 atmospheres, but the temperature is increased. So he's going to increase the temperature. Explain the effect on the yield at equilibrium. So you should remember, if we have a reversible reaction like this, What will happen if we increase the temperature? Remember that if we increase the temperature, I need to look at delta H. Can you see the delta H? Is the delta H positive or negative? It's negative. That means the forward reaction is exothermic. So that means that as the nitrogen and hydrogen react to form ammonia, the reaction becomes hotter. So if I'm going to increase the temperature, then the reaction will go backward. Remember, when we heat up a reversible reaction, it goes to the side that is endothermic. So increasing the temperature will shift the equilibrium to the left, or we say it will go backward. Why? Because the forward is exo, or because the backward is endo. Increasing temperature goes endo. Okay, but he's saying what is the effect on the yield? Well, if the reaction goes backward, that means the ammonia is breaking up to form nitrogen and hydrogen, and that means I will end up with a lower yield of ammonia. Remember, yield means the amount that you will get. So if it's going backward, you have lower yield of ammonia. Then he says the reaction mixture is kept at a temperature of 450, but the pressure is increased. So if I have the same reaction, but I'm going to increase the pressure. Now, what happens if we increase the pressure of a reversible reaction? Remember, in this case, I'm not looking for which one is exo or endo. I don't care. What we're looking for is the number of moles on either side of the arrows. So if we increase the pressure for any reaction, the equilibrium will shift to the side that gives less number of moles or less number of molecules. So which side will give less number of molecules? Well, if we go forward, it forms 2 moles of ammonia. If I go backward, it will form 1 mole of nitrogen, 3 moles of hydrogen. That means a total of 4 moles. And remember, increasing the pressure will shift the equilibrium to the side with less number of moles. So in this case, it will cause the equilibrium shift to the right or the reaction to go forward. And that means if the reaction goes forward, that means more nitrogen and hydrogen react to form ammonia. And that means I will end up with a higher yield of ammonia. Draw an energy level diagram for the reaction between nitrogen and hydrogen. Remember, he said it is exothermic, and that means the reactants are above, the products are below, and the difference in energy from reactants to products, so this is an arrow going down, this is what we call delta H, or enthalpy change. Remember, if we say what is meant by delta H is the enthalpy change or the heat change. At the start of the reaction, 48 decimeter cubed of nitrogen is added to 120 decimeter cubed of hydrogen. Show by calculation that nitrogen is in excess. Remember, if he gives me information about both reactants, so he's giving me volume of nitrogen, so I can get number of moles, and volume of hydrogen, so I can get number of moles. Now we need to decide which one is excess. That means which one is more than needed. So let's first calculate number of moles. We're talking about gases. He gives me volume of the gas, and that means the number of moles is volume over 24. So the number of moles of nitrogen is 2 moles. The number of moles of hydrogen is 5 moles. Now we look at the equation and we see how many number of moles do I need? The equation says if I have 1 mole of nitrogen, it needs to react with 3 moles of hydrogen. Can you see that from the equation? 1 mole of nitrogen reacts with 3 moles of hydrogen. That means that the number of moles of hydrogen should be 3 times the number of moles of nitrogen. Now, let us look at what we found. We found that nitrogen is 2. So according to the equation, hydrogen should be 2 times 3, which is 6. But we have less than 6. And that means hydrogen is not the excess, hydrogen is the limiting. Or if we look at it the other way around, we can say that the number of moles of nitrogen that we need to react with 5 moles of hydrogen. Remember, 1 of nitrogen reacts with 3. So how much of nitrogen will react with 5? It will be 1.7 moles. So I need only 1.7 moles of nitrogen. How much did he add? He added 2. That is too much. That means that nitrogen is excess. Do we understand this? Okay, last question. The yield of ammonia at equilibrium is 20%. Calculate the volume of ammonia formed. So we need to get the number of moles of ammonia. Looking at the equation, what do we see? 3 moles of hydrogen gives 2 moles of ammonia. So this 5 moles of hydrogen will give how much? So 3 gives 2. So 5 will give how much? And that means we have number of moles of ammonia is 3.33. Then I can get the volume of ammonia. It's the number of moles times 24. Remember that this, what we get here is the theoretical yield. So I should get 80 decimeter cube. But he says that the yield is only 20%. So he actually did not get 80. He got 20% of 80. So the actual volume that he got is 16 decimeter cube. Do you understand this? He was supposed to get 80 according to our calculation. But he says he got only 20%. That means what he actually got is the 20% of the 80. So that is 60. Okay, and that's the end of this paper. I hope you were able to understand all the questions, and thank you for listening.